Hello, welcome to Virtual for Real, the Rapid Pipeline Podcast. I'm your host, Max, CEO and co-founder at DGG, creators of Rapid Pipeline. And with me here today on the show is Antonio González Viegas, who is the CEO at that open company and quite pushing the boundaries of what's possible with 3D BIM nowadays. And I'm really looking forward to the conversation already. Antonio, great to have you here. Tell us a bit about yourself.
Yeah, no, Max, thank you so much for inviting me. It's a real honor. Yeah, I am a architect or used to be an architect of buildings that one day was hired by a software company as product owner, but very quickly realized that the work of software developers was cooler than my job. So I decided to make this switch. And then I started building 3D software for the construction industry. So now I have that open company. We are building a lot of open source software, as you can imagine, for the name of the company. And yeah, we are doing great.
Yeah, that sounds like a super exciting journey, like coming from the architecture side, right? And then going into software development because you figured out it helps you to achieve what you want to achieve, right? And we'll get more into ongoing projects of that open company later. Um, so you were just coming from the Next Build conference in London, and so I think you're always in touch like with what's going on in the BIM world. And what we did in the past episodes here at the podcast was we talked with experts from the DPC space, digital product creation, and I would love to learn a little bit about um, any similarities or differences. So what we have seen in the last episodes was that people love to embrace 3D digital twins, but it only makes sense really. It only pays off to its fullest extent when you start embracing it already at the design stage. So let's say you're doing shoes. You design a shoe in 3D, and then you can use it for design review instead of physical prototyping, right? And then once you pick the model that you want to do, you can do virtual store planning. You can do marketing images that are rendered, and you can put them on your online store or wherever you need them. And you can do XR like virtual try-on and so on. So there's like just this whole bunch of benefits, but you need to do it consequentially from the beginning. Otherwise, if you're in the last stage, right, and you don't have a 3D model, and you're like, hey, I want to do virtual try-on, and you have to like digitize each shoe retroactively, right? It's a whole lot of effort that comes with it, and it makes it less worth it. So basically, main takeaway, doing DPC right ideally requires transformation across different parts of an entire org, across the whole value chain where this digital twin is used. And how is that in BIM? Are digital twins already commonly used in BIM? Is it like for most of the buildings or for a minority? And yeah, can you just share a little bit about that and like how is that developing right now?
Yeah, absolutely. It is actually funny because it looks like we are in a very similar position to the DPC space. The construction industry is actually five letters: architecture, engineering, construction, operations, maintenance. And BIM BIM started on the left side of the industry, so architecture and engineering, and now is slowly permeating to the right side. But it turns out that even in very advanced countries like Norway, um, the vast majority of buildings don't have a BIM model because BIM is relatively recent. So you have to think that buildings that were built before um, I don't know, 2010, probably don't have a big model. And still today, modern buildings that are not very big, like single family homes or modest buildings, maybe they don't have a big model because the truth is that the vast majority of architects don't work with BIM yet. So you're right. That's one of the problems of digital twins. The vast majority of buildings don't have a big model coming from the left. So what do you do then, right? So yeah, it's very similar to what you described in
Well,
DPC.
yeah, I mean, I can see that. It's really like starting in the product design stage versus starting in the architectural stage. It's kind of the same thing, right? Like the product designer is the architect of like a shoe or whatever. And it's funny because I, as a layman, I would say in that space, I mean, I have experience in 3D software, right? But maybe that's exactly my bias. Whenever I go somewhere and see like there's a construction and there's a nice rendering of like a big building, right? I'm like, yeah, yeah, they're doing all the buildings in 3D nowadays, but that doesn't seem to be the case. Um, And so how is it like is it something that's just started happening and nowadays everyone does everything in 3D and it's just a problem of the last couple of years, or is it still a majority that's working in 2D in the architecture, like you said, still nowadays? That's actually the case.
Yeah, actually, there was something that Chris from Autodesk Forma said last week in Next Build that I think summarizes the situation very well, which is i- i- he had this slide saying rework is killing our industry. And that
Hmm.
was the very reason why BIM came
Hmm.
along, right? Because architects built the whole design of a building, which means drawing a lot of very time-consuming drawings in AutoCAD or a similar application. And then the client sees it or the construction company sees it and they have feedback, suggestions, things they want to change. And you have to go back and redo it again and again and again. And this is very inefficient, as you can imagine. So the idea behind BIM was something like, what if we are able to automate documentation and at the same time work in a way that allows us to discover the errors earlier so that because it's easier to, in theory, to see the mistakes when you have the whole 3D model and instead of a set of 2D drawings that are an abstraction of reality, right? And everyone liked it. And I think the industry is changing, but it's slow because, most architectural studios don't have huge profits. They don't have big margins to play with the new softwares that comes along, right? At the end of the day, their business is not using software, it's selling buildings or
Hmm.
selling building designs. And the deliverables are usually 2D PDFs. So I would say that yes, everyone's changing slowly, but at the same time, there's no urgency there. So
That's really interesting. And how is it with the software side of things? So just interested in digging a little deeper in the architectural software. Um, Is it a cost problem that architects aren't able to afford like professional commercial solutions for 3D BIM? Or is it a skill problem that they haven't learned to use that software and the software is very complex and hard to handle and they're just faster doing things in the 2D design tools? Or is it a combination of both? Maybe it's both.
my opinion on this topic, of course, is super biased. So if you ask an architect, maybe they will give you another answer. But I would say that the problem is that one of the dynamics that we have in the construction industry is that, I always joke saying that the letters that I said before, ACOM, are ordered from poor to rich. So architects are the poor people, then engineers, then construction companies, and then operations and maintenance are the rich guys. And it is true, if you talk to a modest architectural studio, I'm not talking, of course, about Foster or Zaha Hadid, right? I'm talking like
Sure.
your
Family
friend who is an
home.
architect.
Yeah.
Ask that person how much money they make, what are their margins, and you will find out that if they divide the money that they make by the hours that they spend working, you will see that probably many architects have a cheaper hourly rate than cleaning people,
Mm.
basically.
Wow.
So it is really hard
Mm.
to make things work. And then the software is not cheap. For instance, the most popular BIM software out there, which is Revit from Autodesk, I think the cost is something like it's maybe it's changed, but the last time I saw it, it was 2.5K per person per year, something like that.
Hmm.
So that's a challenge to pay for many people, I guess.
Mm. Okay. And so what are the workarounds then? Let's say, okay, I have the AECOM process basically, and it starts with the architects. But yeah, they're struggling to do things in 3D. And of course, we would love to address that. And I think your company is also helping with that, right? Like we'll get to that later, like creating open tools with open source solutions. But wh- that might take a while, right? And we want to democratize that. But what's happening right now when, let's say, in a later stage of the process, when a building is already there, a digital twin is needed? Like, what happens? Do people then use Revit to recreate it, or are there other ways how people deal with that?
Yeah, it's funny because there's a whole business vertical in the construction industry that's called scan to BIM. And the whole point of this business vertical is that there are companies who make a living simply scanning buildings that are existing but don't have a BIM model
Right.
and recreating the BIM model
Oh.
to for construction, for maintenance, and for operations, right? So this is usually the case. One question that you might have is, once you have the 3D scan, why reconstruct the BIM model? Because in the end, the BIM model is like an abstract, simplified. The 3D scan is much more accurate than the BIM model, of course. And the reason is
Mhm.
because in our industry, people have not yet managed to treat the 3D scan as a set of semantic objects, right? Like the 3D scan is like a bunch of triangles with a nice texture on top and it looks great. But people with the apps that we have today, people cannot still select a column and treat it like a single object and assign properties and semantic data to that column. So that's the reason why people go through the whole process of scanning the whole building and then recreating the whole BIM model and then delivering it.
Right. And it needs to be accurate, right? I mean, the scan is you can quantify how accurate it is, but then if you have an algorithm that does some semantic segmentation in it, I don't know, has a column in front of it and says this is a radiator, that can be quite like I don't know, irritating later, I guess. So you want to make sure everything's accurate, right? And I guess that's why people still do it a lot by hand then. So they have like a 3D scan and they kind of add these primitives or like basically recreate that model based on the scan. Is that how it works?
If you ask me, and again, my opinion is like biased, so if you ask other people, they will give you another answer. But if you ask me, it's just the ability to select a single object and see properties for that object. That's the only problem. If they
Mhm.
were able to do it with a 3D scan easily, they wouldn't need to recreate the whole beam model. In other words, the only benefit of the beam model is that instead of having one big chunk of triangles, you have one column, one slab, one window. That's it. There's no other
Wow.
benefit.
Wow, that's really interesting. So I mean that kind of leads back to the digital twins, right? So it's like you have a scan, but if it's an unstructured triangle soup or point cloud, then it doesn't help because you want to have a digital twin that really represents all the individual parts of your object. And maybe that also leads to like the question of like why are digital twins anyway hard to do in the BIM world, right? I think the challenges are a bit different from what we see like when I talk about shoes or clothing or even I don't know like a whole automobile or whatever. In BIM, it's a lot about geometry, is what I understand, right? I mean, materials are not so important unless you're really doing high-end renderings, of course. But for many use cases, it's about geometry. And then, um, what are the challenges of dealing with geometry and BIM data in the real world? What makes it so hard in particular?
I I wouldn't say that our case is necessarily harder than the case of other industries. The problem that we have in our industry is that the big companies have been accumulating proprietary technology over decades, and nothing is open source. So it's like saying, hey, can you make a video game? And maybe you tell me yes. And then I tell you, okay, but what if I tell you to make the video game from scratch with no video game engines, with no graphics
Mhm.
engine, just write the game in C++. Then the challenge would be a lot higher, right? Because you really have to make a lot of previous steps before even having something in the screen. That's the problem in the construction industry. It's not that we have super high technical challenges. On the contrary, if you take a look at any modest video game nowadays, it's probably way more sophisticated technologically than the big applications that make tons of money from the big vendors. The problem is that until very recently, nothing was shared. So every new incumbent that got into this software space had to create their solutions from scratch.
Mhm.
And as you can imagine, this slows down a lot. So that's one of the reasons why, in my opinion, if you take a look at the software we have in the construction industry, it looks like software from the last century. It doesn't look like modern software like in other industries.
And what are the particular jobs to get done there? So, and the challenges attached to them. So I understand. Like viewing is one thing. How important is viewing, and what are other use cases?
Yes, viewing, you're right. Viewing is a huge challenge because viewing in construction is very different from viewing in a video game or viewing in
Hmm.
a generic 3D scene, right? In construction, we have buildings, and it turns out that buildings have, I'd say that a very characteristic distribution of geometry. You have a lot of unique low poly objects. And the reason that low polyness and uniqueness is related is because the objects that are low poly are generally the objects that you build on site. And there you don't have the technology to build very sophisticated things. And then you have a lot of high poly repeated objects like windows, doors, handrails, things that usually come from a factory. This combination makes it really hard when you are trying to open a building that has millions of elements because you have to
Hmm.
deal with a very, I wouldn't say necessarily hard, but a very unique scenario. So there's not a lot of literature about how to approach this problem.
Right. So it's basically, yeah, I get it. Like a lot of instances, right? And it's very different from, yeah, like how game content is built and so on. And how important is the editing? And like, could you share a bit on on that? Because I understood like you just said many people just want to like view and like click something and identify it. So I understand. But then, how important is it to be able to edit something down the line?
I would say it's pretty important because the whole point of digital twins is maintenance. And maintenance means that maybe you want to refurbish the building, maybe you want to change a window, maybe you want to
Hmm.
change the use of a specific room, and then you need to change the furniture so that the digital twin
Right.
resembles the real asset, right? And right now, editing is something I would say that is not accessible because the only way you can edit a BIM model is usually in the proprietary application. There are no free and open source libraries that allow you to build an easy way to, you know, edit BIM data that you get. We are building it. We are in the progress of building that, but that's a challenge, and that's a problem even for people building digital twin applications with proprietary systems because it turns out that all proprietary systems available for both open and proprietary systems available today just allow you to view. They don't allow you to edit, basically. So that's
Right.
a challenge and a problem that many startups have at the moment. They can just build applications to display, but not applications to edit.
Right. And I would love to learn more about that. So, I mean, what we are doing with Rapid Pipeline is that we're just facilitating loading of, let's say, be it IFC files or be it proprietary formats like Revit, right? You can drop a Revit file, you can optimize it for real time, but then you basically have something to view, like you said, right? And also, the question is like, what is the right viewing technology? And you guys have introduced something that's called Fragments, right? And I see it's on GitHub. It's an open source project. I would love to learn a little bit about what were your like ideas when you started building this? What are your goals? And yeah, maybe any things to share from the first versions. Like, in other words, breaking it down, like why is loading an IFC in some random engine not doing the job, right?
Yes, absolutely. So basically, I started this as a hobby. Now it's a company, and we started building on top of IFC. And IFC is the closest thing we have to a common language in the construction industry, similar perhaps to GLB or GLTF in
Right.
other industries.
It makes sense. Yeah.
And it's a data schema, so it's not a format. It's like just a definition of classes, basically a definition of data. And the format that we use is a step file, which is a very, very old file to exchange CAD data.
Mhm.
And step files have problems. They are text-based, they are hard to parse, and this also bounds to specific problems of IFC. Like for example, one problem with IFC is that most of the times the geometry is just implicit. And that means that you need a geometry engine, which is hard to build. And even if you have a geometry engine, which we have, because we build it, it's also free and open source. You need to be able to perform thousands of geometric operations, including complex Boolean operations, before being able to show the first frame of a building. So as you can imagine, when you try to open a hospital building that has, I don't know, 3,000 windows and 1,000 doors, you need to perform 4,000, at least 4,000 Boolean operations before showing it. And that takes time, especially if you're not in a not very powerful computer. So we found that IFC was not doing the job, or users
Mhm.
were telling us, yes,
Right. Yeah.
it's okay, I can see this building in 30 seconds, but it's not enough. It needs to be faster. Or 1 minute. 1 minute. They are not willing to wait 1 minute to open the building, basically.
Yeah, it's
So,
very like big interruptions, right, in your workflow just to
yeah, and
tessellate
not only that, like every time
some
that you
Boolean
reload
ops.
the browser, because a desktop application, I think, is supposed to be persisted for a longer time. But in the browser, I don't know if it's
Hmm.
because of the way we are educated. We are used to reload, and each time you reload, it's like opening the application again, and they have to wait again for the whole
Right.
model to load, right? So we realized that if we wanted to be faster, if we wanted to be more performant, we needed our own custom format that was designed to do the job. Because I mean, we were at the limit of IFC. Maybe it can be done better. At least we didn't know how to do it. We were out of tricks. Um, so we built Fragments. It's free and open source. It's just a format. And basically with Fragments, we can open, I don't know, we take a 2 GB IFC model, we convert it to a 80 megabyte fragments file that has all the geometry and properties, and then we are able to open it in 5 seconds, even in a modest computer. So, um, yeah, I mean, of course, this number is very biased because we built the technology just to be able to win this fight, this specific fight, right? So, yeah.
That's great. I think it's great to have technology that's like purpose built and really does that job because, yeah, as you said, like IFC seems to be good for exchanging data, but maybe not necessarily for, yeah, like rendering it quickly or getting it rendered quickly, like in, like that setup step that takes a lot of time. Um, and coming from that IFC world, I mean, you are used to having capabilities to edit things, right? And we said earlier that's important. So is that something you're also looking into with Fragments, like eight editing capabilities, now that you can load models very fast and efficiently?
Yes, we are, because as I told you, in this space, every big player and even the new startups, and it's sad because it's a self-perpetuating situation, are building the proprietary technology from scratch without sharing any knowledge. And that means that yes, even if you have an IFC with implicit information, if you don't have a geometry engine that is designed to be able to handle these geometric operations, you won't be able to edit it, right? Yeah. So we were forced to create a geometry engine to be able to build the IFC viewers that we built in the start of the project. So now that we have a full geometry engine, we are basically going to use it not just for reading IFCs, but also for modeling and editing fragments natively.
Hey, that's pretty cool. I mean, if you can solve that, it sounds like such a leap forward. So that native editing, like working towards that promise of open BIM, right, which is connected to IFC. That's super exciting. Are there any other items like on your roadmap saying like what's next? What are you planning to tackle next, and how would that look like ideally uh, within the next couple
Yes,
of years?
I usually, yeah, yeah. I usually like to organize, let's say, the features that you can build in the construction industry, like in big domains. And I would say that visualization, we are pretty good there, at least for the moment. Probably next year we will be already updated, but you know how this goes. Technology goes faster and faster. And there are two domains that we want to attack next. One is modeling, like you asked me, and the other one is documentation generation, because it turns out that even in 2025, the construction industry main deliverable format is still a PDF with the plans in 2D. So being able to generate the documentation or the plans for a building from a 3D BIM model is really critical. In fact, the main reason why people use Revit so much, in addition to belonging to Autodesk, and Autodesk has a fantastic distribution and selling team, um, is because it's a fantastic documentation tool. So it doesn't just allow you to model, and in fact, many people will tell you that Rhino is much better for modeling than Revit, because it gives you so much power, right? the main power of Revit is that it allows you to build the plans in a, let's say, very powerful way. So that it's basically, it's not a modeling tool, it's a documentation tool, even
Ah.
though it allows you to model.
That's a very interesting take. So basically helping with that task of documentation generation and enabling that for your users in a more like smooth and like yeah, painless way is a big challenge and something you intend to tackle in the future.
Yes, yes, you're right. It's a big challenge. It's not going to be easy. And you know how software goes. You start a problem and it's fun, and suddenly it becomes painful. And then you have to go through the painful path until you actually manage to solve the problem, right? So, but I would say that because we are doing all this free and open source, hopefully we are solving this problem for good so that nobody else has to solve it again. So if a startups come and they want to build a product, they don't have to build yet another viewer or yet another modeler or yet another documentation generator. They can just use our open source libraries and use it as a stepping stone, basically.
Perfect. So if people want to learn more about what you guys are doing and are building, what would be the best address to check it out? Is it like that open company, your website?
I would say actually that at the moment, the best way to find out what we are up to is following me on LinkedIn because I'm really spammy there. We have a community. Also, we have a open community, which is people.open.com. So if people want to find more about the project, they can go. It's open and free, so anyone can sign in. And there, people ask about, I mean, it's like a forum. So people tell us what they're building. They ask questions about the technology. It's pretty active. So yeah, many things going on there. We are around 7,000 people for now.
Oh, hey, that sounds great. Congratulations to what you have built so far. And many thanks for sharing all these insights today. I think it was really cool for me, definitely, and hopefully also for our audience to learn a little bit more about virtual, like digital twins in the BIM space and yeah, like seeing all the challenges and the progress in this space. So, Antonio, many thanks for being on the show.
Yeah, no, many thanks for inviting me. It was fun, and hopefully it will be interesting for the audience.